Hello, everyone. My name is Florina Muntenescu, and I'm a developer advocate at Google. And today, I want to tell you about DataStore. So DataStore was created to replace SharedPreferences, and it provides two different implementations, Preferences and Proto DataStore. Preferences allows you to save small primitive data in key value pairs, while Proto DataStore allows you to save small type data backed by protocol buffers. But both of them, both Preferences and Proto DataStore, are using coroutines and flow. So I said that DataStore was created to replace SharedPreferences, but what's wrong with SharedPreferences? Why can't we use it? So while indeed SharedPreferences allow you to save small primitive data in key value pairs, it also comes with a series of disadvantages. So let's see. So first, SharedPreferences has a synchronous API. It allows you to get the SharedPreferences, get the editor, and then in the editor put the ints, for example, the value that you need based on a key and a value. But the problem is that we're working with values like this, put int of a key, and it's very easy to use the wrong key, and it doesn't have that nice type safety that we want. Then when we want to save the value, then we would call apply or commit. And if you're anything like me, you never remember what's the difference between apply and commit, and you have to check it before you use it every time. So apply actually allows you to change the data in memory immediately, and then it asynchronously makes the data on disk, while commit allows you to change the data on disk synchronously. So we use the idea of on disk because under the hood, SharedPreferences just saves the data in a file. Okay. So this means that especially if you use apply, SharedPreferences doesn't have a transactional API with strong consistency guarantees to know that indeed once the data is changed, it's already consistently saved. But also, it's actually not really safe to call on the UI thread, especially when we talk about commit that changes data on the disk synchronously. So this means that you end up doing long-running operations on the main thread. And you'll say, okay, fine, you know what, then for async API, I'll just use the editor apply. But apply actually also comes with a caveat. So under the hood, apply actually schedules some calls of the fsync. So this is the time when actually the data gets to be saved. And on fsync, the fsync call actually blocks the UI thread. And you actually don't really control when these calls are triggered. They actually trigger when an activity or a service starts and stops. So this means that every time you're starting or stopping an activity or a service, you might get an extra delay on the UI thread just because you're saving some data in SharedPreferences. But SharedPreferences also has an async API when it comes to reading the data. So you could use register on SharedPreference change listener that will trigger every time a SharedPreference is changed, added, or removed. But this one also comes with a caveat because the callback will be run on the main thread. But we said that SharedPreferences saves the data on file. So what if something goes wrong with it? Well, the thing is that SharedPreferences can't signal errors. And even more, parsing errors are thrown as runtime exceptions. So it makes it even harder to handle those specific parsing errors. And what if you want to fix all of these things? Well, that makes it really hard because the SharedPreferences is bundled with the Android operating system. So even if we fix all of these issues of SharedPreferences in the platform, then it will take a while until you'll be able to take advantage of these new APIs, and they won't be backwards compatible. So to address most of the issues that are of the disadvantages of SharedPreferences, DataStore was created. While indeed DataStore doesn't have a synchronous API, most of the other issues are addressed, including type safety, which is addressed with Proto DataStore. So synchronous API, async API, safe to call on the UI thread. So this means that you could be using Room, right? Because Room addresses all of these issues. And the thing is, if you are using large data sets, if you need referential integrity, if you need to query data, if you need partial updates, for all of these, don't use DataStore, use Room. But if your data is small, if it's simple, if it doesn't have any queries, then you can just use DataStore. Okay, let's take an example and then see how you could use DataStore. So let's say that we have a to-do list app. So in our to-do list, we can also mark a task as completed. And we also want to have a toggle at the bottom that shows or hides those completed tasks. And because this is a user preference toggle, this is something that we want to make sure that we persist. So let's see how we can save this with Preferences DataStore. So Preferences DataStore allows us to save small primitive data in key value pairs. We would get a reference to DataStore by calling create DataStore and passing in the name of the preference. So we'll see here that we get a data store of preferences. This preference object is actually from data store, so it's actually not related to the preference objects that you might know from other libraries. Under the hood, actually, data store saves the data on file, so on the disk. And actually, even more protobufs are used independent on whether you're using preferences or Proto DataStore, but this is hidden from you in the Preferences DataStore. So let's see how we read the data. So to read the data, DataStore provides datastore.data that returns a flow of preferences. So these are immutable preferences where we can just read from. But because we might be only interested in the show completed flag, we can just map our flow and then get the show completed value from it based on the key that we've defined. Also, if the value doesn't exist yet in DataStore, we can define what is the value it should be returned. So Preferences DataStore right now supports int, long, boolean, float, and string, and in the future it might also support double. So really just these primitive types. So because DataStore in the end saves data on file, this means that, again, exceptions can be encountered when reading data. So to signal this DataStore.data also throws an IO exception. Because this is just a flow, just handle it in the same way you would handle any other flow. So for example, here I'm using the catch operator, and then if the exception is IO exception, I know that for sure this is an error due to reading preferences. So I'll just omit the default value, for example, and otherwise I'll just throw the exception. Okay, let's see how we write data. So to write data, DataStore provides datastore.edit, a suspend function. So in the lambda of it, we get a reference to a mutable preference. So this is the one that now we can change. So we can easily just set preferences of our key equals and our new value. So the important thing with write data is that it's an atomic read, modify, write operation. So when edit is called, the latest value is read of the preferences. Then you modify it, but only, of course, that specific value or specific preference that you modify gets to be changed. And then afterwards, the preference is written on disk, and only after the preference was written on disk, only then the coroutine completes. So this means that you can really ensure that we have a transactional read, modify, write operation. But again, because we're working with files under the hood, datastore.edit can also throw an IO exception. Also, because we want to make sure that we don't do any long-running work on the main thread, by default, edit runs all its work on dispatchers.io. But if dispatchers.io is not the ones that you prefer, and you prefer using your own dispatchers, the create data store method also passes another value, or allows you to pass another value, which is the coroutine scope. And then in the coroutine scope, you can use the dispatchers that you want. Okay, so you already have shared preferences in your app, and you're thinking of migrating to Preferences Data Store. How do you do this? Well, to do this, when creating the data store, you also pass in a migration. So DataStore provides a shared preference migration, where you just pass in the name of the shared preference. And then DataStore will actually do all the heavy lifting for you. Because both DataStore preferences and shared preferences are a key value system, then DataStore just knows how to copy one from the other to the other. One thing you need to remember is when you're actually working with the preference, make sure that you keep using the keys that you've used before for shared preferences. Okay, so let's see how it works with Proto DataStore. So there are actually a lot of similarities between preferences and Proto DataStore, so I'll only focus on the things that are different with Proto DataStore. So this allows us to save small typed data backed by protocol buffers. And if you're like me and you never worked with protocol buffers before working with DataStore, let's do a super tiny crash course in protocol buffers. So protocol buffers are a mechanism for serializing structured data. It's small, it's fast, and it's simple. So to work with proto buffers, you would create a proto file. So in this file, you would create a message object. And then in that message, you would define fields. So for example, here I define a show completed field of type Boolean. And then that one is a unique identifier that protobuf uses under the hood. So what protobuf does for us is at compile time, create an object from these messages that we define in proto. But what's actually really, really cool with the protocol buffers and with Proto DataStore is that we can use any type here. So let's say that we expand our to-do list. Let's say that in a to-do, we also have a deadline and a priority. And we also want to be able to sort our tasks based on that deadline and priority. And of course, we also want to make sure that we persist that setting. So this means that we can define an enum that's called sort order that has none by deadline, by priority, or by deadline and priority. And then we just add the sort order as a field of user preferences. And that's it. So the compiler will generate for us the user preference object, the sort order enum as a nested class of user preferences, and user preferences would have both show completed and sort order as fields. For DataStore to know your protos and to know how to interpret them, you will also need to create a serializer object. To be honest, this object is pretty simple. And if you have multiple messages or multiple data stores, you'll see that you'll end up just copy-pasting the same class, just replacing user preferences with whatever new message that you have there. Then, when creating the data store, apart from the file name to be used by DataStore, you would also pass in the serializer. Reading data, it's very similar to the Preferences DataStore. You just do datastore.data, and then in return, you now get the actual user preference object that you defined in the proto. So this means that this will hold all of the preferences in that specific data store. And then if you only want one preference specifically, you can just map it like you do with any other file. To write the data, you would use datastore.update data. And this one, just like preferences, is an atomic read, modify, write operation. Just that this time, we get as a parameter the latest value of user preferences. We will then transform that reference to a builder, set the value that we want to change, and call build on it. Under the hood, DataStore will make sure that it saves the information on file, and only once that is done, the coroutine will complete. So how do we migrate from SharedPreferences to Proto DataStore? Well, to do this, it's not really as simple as it was with preferences, right? Because right now, DataStore can't by itself know how to map the key value pairs to these new objects that you define in the proto. So it will just need some help from you. So you would implement a SharedPreferences migration. So here in the callback, you would get the SharedPreferences and the current data, and you'd have to define this mapping. So for example, you would get the show completed flag from SharedPreferences, and then in the current data from preferences, you would set the completed flag and then build it. But there's a little caveat here. So SharedPreferences migrate. So in general, actually, the migrations are triggered every time the data store is created. So let's see a little bit what would happen. So let's say that in SharedPreferences, our show completed flag is true. By default, the value in the data store would be the default value for Booleans, which is false. So the first time when we initiate the data store, then the migrations are run, and then we're copying the value from SharedPreferences to data store. But then our users modify the flag, and then data store show completed flag is changed to false. Then the next time data store is initialized, it will just try to, well, migrate the data again, but that's not something that we want, right? We don't want to every time rewrite the data from shared preferences. So DataStore will need a little bit of help from you. It will need to know when the shared preferences migration is done. So what I would suggest is use something like a shared preferences migration flag. And then based on that, when you implement the shared preferences migration, you just check, is the migration done? If not, just copy the data that you need, and that's it. And also make sure that you're setting the migration done flag. Then afterwards, make sure that you're setting the shared preference migration in the list of migrations when you're creating the data store. So if you think about the data that we have usually in shared preferences, the data comes pretty much from everywhere, right? You'll have key value pairs from all sorts of features that have no connection to each other. So usually, okay, you could just save all of this into one data store, but the thing is that it's not really always what you want, right? Every time one of these values changes, the flow will emit again, and will emit, and when doing that, it will read all of the information in the file again, so it can emit the new preferences. So this means that even if, let's say, you're only interested in the notifications enable kind of flag, you'll get updates for this kind of preference change, even when show completed was triggered. So if you think about how you would model data, chances are you wouldn't keep all of these preferences also in one class. You would probably want to keep them into two separate classes. So you could do the same when we're talking about data stores. So you can separate the information that you need in multiple data stores. In the end, under the hood, it just creates a file. At the same time, there is a balance that needs to be reached between how many files you read, because in the end, it still takes a while to open and close the files, but keep in mind that you can still do this. So, preferences and Proto DataStore. So, we said that they bring all of these advantages and disadvantages compared to shared preferences. So one thing that I didn't really talk about was the synchronous API. And that's because we don't think you should be doing long-running operations on the UI thread. But if you really, 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 really need to do this, here's how to do it. You would just call the run blocking. And then from the datastore.data flow, you would just get the first element. Then we saw that DataStore provides an asynchronous API, both for reading data and for writing data. It's safe to call on the UI thread because under the hood, DataStore ensures that the writing of the data happens on dispatchers.io. Then it can also signal errors because both reading and writing data throws IO exceptions that you can handle yourself. Finally, it provides a transactional API with strong consistency guarantees. Both update data and edit data are an atomic read, update, write operation. So you know for sure that you can rely on the data from DataStore. And it also handles data migration. With the in the list of migrations, you can define both shared preference to DataStore migration, but you can also define migrations between different versions of data stores. So for example, if the data that you're saving is changed. And this is something that we haven't reached, we didn't manage to talk today, but it's something that you can find or read more. And then finally, Proto DataStore also gives you type safety. And not just type safety, it's also type freedom, right? Because you no longer just need to save primitive values. You can save any type of data. And it's unbundled. So this means that you can start using DataStore independent of the Android API level that you're using. So check out the documentation, check out our code labs for more hands-on experience with DataStore. Thank you. And I think we don't have time for questions, but I'll be on Twitter, so hit me up on Twitter, but also on Talk for on the chat for more questions. Okay, wait, we have 20 seconds, so maybe how do we add encryption? Well, right now, DataStore doesn't support encryption, but that's something that we work on. So there is already an issue on the official issue tracker, so I suggest starting that issue if you want to follow it. Is it possible to use DataStore without Kotlin coroutines? Not right now, but we are working on support for RxJava. Why move to protobuf away from Android's parcelable? Protobuf is just a simpler and easier way to save the data, but I don't know enough to tell you more about that. Encryption, I think we already covered that. Emitting false in the catch operator will emit false as a fallback value, and the flow will complete right after. This means that we will lose the notification from the new data. The same happens when with room exposing the flow. I don't think it. I'm not sure. It's just like DataStore production ready. If not, when we can expect the final release. Keep in mind that we only released DataStore, a month ago or maybe 6 weeks ago. So it's still in alpha. It's still in alpha 01, actually. So I can't tell you when we should expect a stable release. Is there a plan for DataStore to not depend on Android-specific components? Well, I think if you're talking about multi-platform, then this isn't happening right now. But not really. I'm afraid that in the end, it's still an Android library. Is there a DataStore inspector? No, it's not. We don't have one of that. Do we need to specify mode private for preferences DataStore? And the question moved. Can other apps access data in Proto DataStore? So there is no longer this mode private for preferences DataStore, and I think other apps can't access data from DataStore, but I'm not 100% sure. Encrypted share preferences with DataStore, not for now, we're in progress. Why the create method has a scope parameter instead of just a dispatcher or a context, and the questions just disappeared. Because we're in alpha, because we needed this kind of a feedback where you're telling us that, hey, a coroutine scope is not right, it should just be a dispatcher. So help us out, help make the API better. What granularity would you recommend for separate store? One store per screen, data that is likely to change together? I would say both. It depends on the data that you're saving. I think in general, like one store per screen sounds about right. But that's also because that's the kind of data that tends to change together, right? Does the data store work with preferences fragment? Not right now. Can you send the example link? Check out the documentation for on our developer.android.com because you'll find all the links there. How about multiple access reads writes? That's also on our roadmap. And I think that is all, and I spoke faster than I ever spoke before. Thank you all for the questions and for watching this talk.